Hey, what's up guys? You're watching Things Like Physics. I'm your host, Jory Pacheco, and today we're going to be discussing the 4 laws of thermodynamics. Okay, so you're sitting in class and there's this guy up front talking about who knows what, and you're just thinking, when is this gonna end? Well, I know that feel. So come on over to YouTube. We have cats, we have bacon with a side of bacon, topped with bacon. We have every fandom you can think of. And we have things like school. Thermodynamics is a branch of science that deals with how heat relates to other forms of energy. Thermo, meaning heat. Dynamics, meaning how it acts with other energies in the systems. Yeah. The first law we're going to discuss is called the zeroth law, and it's a weird one because it was actually discovered after the primary 3, but it was deemed so important that it had to come before those 3. So instead of renaming all of them, they just called it the zeroth and put it first in line. Now I know the zeroth law seems really simple, but it's actually super important, and without it, we wouldn't even be able to measure temperature at all. So the next law we're going to talk about is obviously the first law, which was the primary law that was discovered way back when all the science laws were being discovered. It is that energy cannot be created nor destroyed. It merely changes form. And a good way to think about this is, let's say you have 100 indestructible blocks. Nothing you do is gonna destroy them, and you can't create any more. So you can paint them red, you can paint them blue, but they're still blocks. Just the way that energy can be heat or energy can be work, but it's still energy. And I could use these blocks to, say, build a castle, or I could only use half of them to build a boat. Either way, I would still have 100 blocks. Alright, now for these next 2 laws, you're going to have to understand something. It's a term called entropy. Now basically what entropy is it's the measure of how disorganized something is. So let's say you have a container of gas molecules. And if all the molecules are gathered here in this tiny corner, then it's very organized and the entropy is very low. But once those molecules start to move out and fill the rest of the container, then the entropy gets higher the farther they move out because they become more disorganized. Just to make sure I've driven that point into the wall. Disorganized entropy. That's where we're going. Or, let's say you have a ball that's flying through the air. Now the energy that used to be in the ball is now being spread out through all the air particles as well. So the entropy is getting higher because the particles are becoming more disorganized. And that brings us to the second law of thermodynamics, which states that the entropy of an isolated system tends to increase until the system is at equilibrium. Assuming that the system was not at equilibrium before. That's very important. I'm going to mention that. So imagine you have a bucket of hot water and you pour a glass of cold water into the hot water. So now you have a thermodynamic system where the particles of cold water are going to gradually separate and grow farther apart so that the entropy gets higher over time until all the molecules are the same distance apart and you have warm water, and that would be considered equilibrium. And finally, the third law of thermodynamics, which states as a temperature reaches absolute zero, the entropy will decrease. It's pretty much the opposite of the second law. It's actually not the opposite. It's just it's pretty much saying the other is true, which means if you freeze your hot water, then the particles are once again going to condense. They're going to become much more organized, going to huddle into that corner, and your entropy is just going to be a lot lower. Hey, thanks for watching Things Like Physics. I'm your host, Jory Pacheco. Join me next time when I sing the quadratic formula.